All right, so we just finished talking about the how to find the displacement of a particle. But let's talk about how to find the total distance traveled by the particle. So like if the particle starts here and goes this way and then comes back this way and then goes that way and ends up here, I don't want the distance from here to here. I want the actual distance traveled. Like if it's me walking, I want to know how far I walked. Even though I'm just walking on a track, I want to know my total distance. So that's different than displacement. With displacement, you just integrate the rate. But think about total distance. Like you might walk forward and then backward and then forward. So if I want the total distance, this area represents a positive area. This is a negative area and a positive area. And these are the rates. This isn't really walking forward, sorry. That's a positive rate, so I'm speeding up, slowing down. Positive velocity. Negative velocity means I'm going backwards. Positive velocity again, okay? So these are positive areas and negative areas. So if I want to find the total distance traveled, including my velocity going in the positive direction, even this distance going in the negative direction, and this just distance going in the positive direction, I would need to add up those three areas, but this is a negative area. So it's like I have to do the absolute value of that negative part because I want to add that up as a positive value. So it's almost like I'm flipping that A2 region up here above the x-axis. Well, what takes everything and makes it positive? Absolute value. So if I want the total distance, not just the displacement, displacement is integrating the rate. Total distance is integrating the absolute value of the rate. All right? So if I want the total distance a particle travels from t equals 1 to 5 seconds, so total distance, not just velocity, I'm going to integrate the rate, but I'm actually going to integrate the absolute value of the rate so I can get my total distance traveled. Remember, to integrate absolute value, you're going to need to know where the function changes from positive to negative and in which part it's positive and which part is negative. So let's take a look at the graph. Alright, so here's the graph of x cubed, or t cubed minus 10t squared plus 29t minus 20. From 1 to 5, this is the region we care about here. Oh, sorry. So from 1 to 5. Notice from 1 to 4, the function, the velocity is positive. So this area, this total distance in here will be positive. But from 4 to 5, the velocity is negative, so the particle is moving backwards. So this distance will be subtracting from our total distance. So if we were finding displacement, we'd add up this positive rate and this negative rate. I mean the positive area, which is the integral of the rate, and the negative area, which is the integral of the rate, to get a displacement. But we want the total distance traveled. So we really want to split up our integral at 4, use the positive integral from 1 to 4, and then do the opposite of the integral from 4 to 5. Alright, so from 1 to 4, we're going to use the integral as is, or the integrand as is, t cubed minus 10t squared plus 29t minus 20 with respect to t, plus the area from 4 to 5, but we want the opposite of the area because we want it to be positive. So you could either do minus the area or just put the negative inside here, just as long as you do the negative of the whole thing. So you need to know where the absolute value changes sign, and on this one we could have factored it, but it's pretty difficult to factor. We could use the calculator. Usually you just set the integrand equal to 0 if it's easy to solve, and find where that equals 0, so then you know where it splits up. And then you need to figure out where it's positive and where it's negative, so that you know if it's if we're going to use a positive or a negative for which part, so that we end up with two positive pieces. If you were looking at the graph, here's our 1 to 4, and then we're making our 4 to 5 be like that. So that's what we're doing, is we're switching this part to be a positive. And then you can integrate that and calculate it all out. I'm not going to take the time to do that. You get 71 over 6. Excuse me. Since the units on this were feet per second, the integral, the total distance traveled, would be feet. Oh, this was the page I was going to do the work on. There we go. So your homework is page 294, 67 through 109 odd. Remember that when you integrate, in order to integrate, the function has to be continuous from the lower bound to the upper bound. Just remember that for the true false at the end here. All right?